Hey everyone, it's Justin again. You've been learning how to use and solve quadratics in factored form and vertex form, but we kind of skipped over standard form after learning what it is. In this video, you're finally going to learn how to solve quadratics in their most common form, standard. At the end of this lesson, you will be able to solve quadratic equations by first writing them in standard form. To get started, we'll quickly review standard form. Then we'll work through 3 examples of how to use standard form to solve quadratics. Make sure you're taking notes because these examples will have a lot of steps. Just a reminder, standard form is when a polynomial has its terms listed in descending order of degree or exponent. For quadratic expressions or functions, there will only be a maximum of 3 terms, with the exponents going 2, 1, and 0. Sometimes a term or two might be missing, but that just means the coefficient is 0, so it becomes invisible. Standard form is how quadratic functions are usually expressed, which is why it's called standard. If we wanted to solve this equation, how would we go about it? Remember, when a function is equal to 0, you're looking for its root. We already know a way to find roots. Find the factors. We need 2 numbers whose product is the constant, in this case -3, and whose sum is the middle coefficient, which is -2 in this example. -1 and 3 multiply to make -3, but they add together to make +2, not -2. We get the same product with 1 and -3, but this time the sum is -2, which is what we wanted. We found 2 numbers that work. So now we use those to complete our factors. X plus 1 times x plus -3. Adding a negative is the same as subtracting, so we can simplify it. Now to finish finding the roots. We take each factor and set it equal to 0. When we solve each of these, we get x equals -1 and x equals 3. So our solutions are -1 and 3. With most quadratic equations, though, they won't be set equal to 0. And that's a problem, because it's basically impossible to solve them without being equal to 0. So what can we do? We can manipulate it so it is equal to 0. If we add 2x to both sides, we get 9x on the left, and it's canceled out on the right. And by subtracting 5, we can move it over to the left side. With all the terms on the left, that leaves 0 on the right. Now we can factor it to find the solutions. But remember, not all factoring is as easy as the previous example. When the quadratic function has a leading coefficient, the process is a little different. First, we should look for a GCF. But there isn't one here, which means instead we need to try the AC method, which you learned about in the last unit. Similar to the previous method, we need 2 numbers with a particular product and sum. With the AC method, however, the product has to be the same as 2 times -5 or -10. The obvious possibility is 2 and -5, but the sum doesn't come out right. So can you figure out 2 numbers with a product of -10 and a sum of 9? Ah, of course, -1 and 10. This is where the process is much different from the first example. Those 2 numbers you got are what you split the middle term into. We've essentially uncombined like terms. But there's a reason for that. By splitting the middle term into 2 terms, we can group the terms together. Now we can pull out a GCF of x from the first group and a GCF of 5 from the second group. You see how the parts of the parentheses match? That means we've done it right. That's one of the factors, and the GCF we pulled out creates the other factor. For this factored form to equal 0 means either of the factors can come out to 0. We just have to solve. Add 1 to both sides, divide by 2, and one of our roots is 1/2. The other one just takes 1 step, subtracting 5, and we get a root of -5. Let's do one more example. Do you think you'd be able to solve an equation that sets one quadratic equal to another? Pause the video. Remember what we had to do in the last example, and see if you could do it again here. Remember, The easiest way to solve a quadratic equation is by having one side be 0. To do that, we need to zero out everything on the right side. So we subtract 2x squared, add 15x, and add 27. Now all the terms are moved to the left side, and we've got 0 on the right. Now we have to factor. What's that first step we should always look for, especially when there's a leading coefficient? Oh, right. We should see if there's a GCF. All of these terms are divisible by 7. And now the remaining polynomial doesn't have a leading coefficient, so we don't need the AC method to factor it. We can use basic factoring to conclude that our factors are x plus 4 and x plus 1. Now that we factored it, we can set each factor equal to 0 to find the solutions. What x value makes 7 equal 0? There isn't one, because 7 is always 7, never 0. There's not even an x there to plug into. If x plus 4 equals 0, then x is negative 4, because negative 4 plus 4 is 0. And if x plus 1 equals 0, then x has to be negative 1. Our solutions are negative 4 and negative 1. If you're thinking, but Justin, I thought originally we wanted the two quadratics to be equal. Watch this. One of the solutions that we found was negative 4, which means if we plug that in for x, it will make this equation true. Let's simplify it and see if it works. On both sides, negative 4 squared is 16. Remember, a negative squared is always positive. 9 times 16 is 144. 20 times negative 4 is negative 80. 2 times 16 is 32. And negative 15 times negative 4 is positive 60. Now we just need to combine all these constants together. 144 minus 80 plus 1 is 65. And 32 plus 60 minus 27 is also 65. An input of negative 4 makes both quadratics output the same value, 65. So in other words, when x is negative 4, the quadratics are the same. So negative 4 is a solution. Checking the other solution, negative 1, would work the same way. Try that out for yourself. To solve a quadratic equation, zero out one side, factor the other side, then set those factors equal to 0. If you need a refresher on factoring, check out the resources available in Unit 13 on our website. Make sure to practice this skill, because in the next video, we'll take it a step further and learn how to solve even wackier equations. See you then!